going to cover what's coming up next with NVMe fabrics. And if you remember what we did when we first started out with NVMe, adding another transport. This is TCP is going to be the fourth transport for NVMe. One of the things we wanted to do with the version 1.0 was when we first started out, actually in the early days we started out as NVMe over RDMA, and people said, well, that isn't general enough. Let's generalize this. Let's come up with a model that can support multiple transports very easily. So that's where the concept of NVMe over fabrics came in, and defining it such that the architectural model is shared and a transport just becomes a transport. So it's not affecting the architecture, it's really there for transporting the operations and data. We started out with the two transports in version 1.0, RDMA, because like was said before, it's really a pretty nice match in efficiency and architecture for NVMe, and plus it covered a lot of different types of fabrics like InfiniBand and Ethernet. So it was a good place to start. Fiber channel, is obviously because it was reliable, credit-based. It was sort of the de facto attach for a storage array in the front end. Very prominently out there, and it just made sense to for these two to be the first transports. So what we're seeing is in the data centers, there's quite a bit of installed base of existing data centers that are using block storage. Maybe they're using like an iSCSI or a proprietary. And what we didn't cover with NVMe is we're having customers asking for NVMe over fabrics in these type of existing data structures environments. So this is really where the NVMe-TCP came in. And like I said, it's coming in as the fourth NVMe transport, PCIe RDMA fiber channel. This is going to, the purpose of this is really to enable the use of NVMe over fabrics in existing data centers, with Ethernet or IP-based networks that, let's say, don't have RDMA NICs at the endpoints, but yet they still want to have an end-to-end NVMe model, and they're willing to sacrifice a little bit of efficiency to get that model, and then maybe they'll migrate over to an RDMA, or maybe have half and half, things like that. But what this does essentially is support it on all IP data center fabrics. It'll support all the NVMe over fabrics and NVMe architecture features, the multi-queues, essentially the encapsulation model, the efficient transfer of data. So all those will be supported as what's defined in the base NVMe specifications. It's going to be layered over standard IETF TCP transport so that we can get a software-only implementation. And this is important for the ability to get it deployed in various endpoint OS environments. We're not precluding folks taking it and accelerating it or offloading it. So as we're defining it, we want to give that as an option, but that's an implementation-specific option. But we've learned a lot over the years with iSCSI offloads, how to do it right. So we're just, as we're defining it, we're using that base. The usage model in here is really, as I said before, it enables the use of NVMe-IO or NVMe over Fabric IO in existing IP data center environments. Software only host driver can be placed over there on your host boxes, and then a software only target can be used. And what this is doing is allowing for efficiency, much like we did with the version 1.0, where we're eliminating the SCSI translations from the host to the NVMe drives. If we're going NVMe end-to-end with the NVMe over TCP, it's a pure non-translated model of operation. We expect this to coexist with the other NVMe over Fabric transports. So for instance, there may be deployments that have partially RDMA-enabled hosts and targets in combination with IP attached hosts, and based on policy or based on maybe the hardware support on one of the endpoints, they can choose which one to use. So that's, we see that being used as sort of a migration path potentially. Another usage model here is as we're starting to build these NVMe over Fabric networks, you may have heard Myron mention enclosure management, and then there's been some other talks about sort of enhancing the mechanisms for endpoint management on, let's say, non-managed fabrics like IP fabrics, or then also sort of augmenting into managed fabrics. But one of the things here is we wanted to enable NVMe over Fabric in-band operations on control path networks. And really what this is it has to do with, like, say, an endpoint that has a low-powered BMC processor. They're typically not attached to RDMA NIC, so it wouldn't be doing, that for its in-band communication. By enabling this NVMe over TCP, we can put that into those style of processors and get the in-band NVMe management interface model operational. And same with the discovery service usage model. Let's say, for instance, you have a large fabric of let's say either fiber channel or RDMA, but you want to sort of centrally manage it out on a network that isn't attached to either one of those networks. What this is going to provide is a mechanism to get the NVMe operations going between the target endpoints and the host endpoints to a discovery type service that's out on a regular IP attached network. So the status of this really is it's currently in definition within. It's been approved for by the NVMe org to do it. It's in definition. It's within the technical working group. We expect it. I'm not going to give a time frame. We expect it out relatively soon. If you want to know more details about it, if you're an NVMe org member, you can come in and get involved in it. Otherwise, you have to wait for the specification to come out. We're going to do the same thing we did with 1.0, where in conjunction with the definition of the specification, we're also developing the drivers for both the host and target drivers, so that we can have those all ready to go when the specification gets released. The drivers for the Linux kernel would be provided for folks to use. There's 2 demos of pre-release version of this out on the floor, assuming the floor opens. SolarFlare has a demo in their booth of a example of NVMe over TCP in sort of the pre-standard version, but they're working with us on the standard. Same with Facebook Lightbooks Labs have a demo of this in their booth, so you can go stop by and look at how those pre-standard demonstrations are working, and it's sort of reflective of what we'd expect with the standard version as it's being defined, since both companies are actively working on that definition.